Hi guys, this is Narendra. Let's talk about Stream API today. As you know, Stream API is a very important feature from Java 8 onwards. In this session, I'm going to explain what is the Stream API and what are the benefits we are getting. I'm sure if you go through this session, you will get exactly what is the Stream API and where to use this. Okay, so collections, right? So collections, if you wanted to apply some operations under a collections object, okay, so in that case we'll go for Stream API. Okay, so we want some operations uh, in a bulk of object, in a bunch of group of object, that can be a collections object. Okay, so instead of going all this theory now, I will explain one by one, and let create a demo example. It will be more clarity. Okay, so I will create a stream demo. Let's say stream demo class, create a class. Okay, and here what I'm doing, I will initialize a list. Okay, let's say a list of integer. I will say my list. I will initialize by using this arrays dot asList, and I can say 2 1 6 3 4 5, something like that. Let import it. Okay, so the now in this is a list. Okay, in this list I wanted to find or filter only the even number. How we can achieve without using Stream API? So what we will do, we'll iterate this list and we'll check whether it is even number or not. If it is even number, we'll assign to a new list, and like this we'll print that new list to get all the even number. That way we can do, right? So let me iterate it. I will use a enhanced loop. Let's say for each loop for int n my list. I will iterate and I will check if this n percentile 2 equal to 0, then you add to a new list. So I will create a new list. Let's say integer new list equal to new array list. So I will add to that new list. So we got all the even number to this new list. Let's print that new list as well by using another enhanced loop for int I colon new list. I will simply print like that I. So if we print this, you see 264. This 264 is the even number, all are odd numbers. So it is printing. So here also using instead of using two for loop, in one for loop we can print here itself. Okay. Anyway, this for loop is the external loop, right? This enhanced for loop, this is the external loop, and the code also a little bit more code we are writing, right? If let's see without using this, by using Stream API, how we can achieve this. Okay, so what I will do, I will comment this code, and by using Stream API we'll write it. Okay, so if we'll call this new list, if we'll call this stream. Okay, stream method, if we'll call this, you see we are having stream and parallel stream. This parallel stream is more powerful than stream. That means parallelly it will execute multiple threads. Multiple threads, it will execute this list, it will process this list. Okay, so that means we no need to create multiple threads. This Stream API will take care of it. Parallel stream we'll see later. Let's see in this stream. Okay, so if we'll call these streams, so on this my list, if we'll call, it will return a new stream. You will see it is returning a new stream. Let hold that stream. We will initialize, let's say, I will say data. I will import this. Okay, and this data, if you'll see, we can call this data, we are having a filter method. It's a stream object, right? This data, so it's a stream object. So in that we can call filter, and here we can pass like this: n percentile 2 equal to 0. If it is even number, then return that number. So this filter, it is returning another stream, you see. So let hold it. I will say it is a filtered data. And that filter data, we got all the even number in this, right? So we can print that filter data by using this for each loop. So I can print like this. See, it is printing, right? 264. So what we did, we created a stream object by calling that dot stream to that list, and that stream data we got, it is not editing here, right? It this is the original list, our original list. Okay, so this list is immutable. We are not modifying this list. Instead of that, we are calling that stream, we are getting a new stream, that new list we are working, and that new list we call that another filter method. We got another stream, this is a new stream, and that stream we are printing it here. So let remove this, and we'll remove all the unused input. So you see this, that means due to the stream API, we are able to write this code in a simplest way, right? And you see what happened, this stream, what is doing, we created the stream and we process it, then we consume it. That means we are terminating three steps. It once we consume a stream, we cannot reconsume it. It's like a water, once we use it, we cannot reuse it. So if I write filter data, if I will write one more times, if I will try to consume, it will say, hey, you already consume it. Okay, already you processed. You see, in fast for each it is printing second times, if your stream has already been operated. Okay, so on the fly it is creating and it is closing, so it is faster. And this line of code we can write even like this. So we can, instead of initializing this, we can call this, on this stream we can call this filter method. So this line is not required, and here itself we can call this for each. No need to initialize here. So let on is input we remove. So it is giving same result, right? 264. So we call this stream, it is a different stream, and upon that we call this filter, we got another stream, and it is filtered to the even number, then the same stream, that stream we are printing here. Okay, so the stream actually, it is not like collections, you see this array list having data structure, this map how it is storing, how it is getting, it is having data structure, it is storing something and it is extracting, okay. But the stream on the fly it is creating and it is not storing anything. Once the control will come out, it will be gone. So that's why it is very fast and it is providing many more operated. Like you see, we created a stream, okay. Then what we are doing, we are passing some operations like filter, we did some operations. So this is intermediate operations, we can say. And after that we are printing, we are consuming, this is terminate operations, okay. If we'll go to our theory, so what is happening here, we created a stream, okay. Then we are processing it, we can process by calling map, filter, many more method is there, okay. So after that we are printing, that means we are consuming it, that is for each loop or redo something you can call, okay, that is terminate. So sorry, so three things is happening, we are creating, then we are processing, then we are printing and terminating, okay. And this stream actually it is working in the original data structure, it is not editing that, okay. It is creating a new, means it's not changing that original data structure, okay. It is creating a new stream and on that it is working and it is more faster. On the fly it is creating and closing, okay. And once we visited, we saw, right, we if we print that stream and one more time we are not able to print, we if we consume a stream, then we cannot reconsume it. So once we visited a stream in the lifetime of that, we cannot revisit, okay. And like we can do multiple operations, we saw filter one operations, right, we can do multiple operations, we can sort it, we can do some more operations. So that is stream pipelining, we can say it is stream pipelining, we can say it is intermediate operations. And it also support terminal operations as I showed you, right. And aggregate or terminal operations. And parallel stream also we can use, it is more faster, multiple threads, okay. It is at a time it is working like multiple uh, process happening at a times at once, okay, if we use this parallel stream, okay. And you saw, right, the stream is whatever original data we are providing, the same order it is maintaining, you see here. So it is iterating 2 1 6 3 4 6 3 4 5. So first he got 2 is the even number, then 6, then 4, right. You see 2 4 6. If you wanted to sort it, okay, we can call here, we can call sort method, we can call sort method here. You see sorted. So it was printing 2 6 4. Now it will print in sorting 2 4 6, okay. So this is the intermediate operations. Even suppose you wanted to multiply each number into 2 and you wanted to print it, okay, you can do that. You can call like map, this map here you can call map. This map what it is doing, it is whatever collections you are calling, right. So in these collections you are calling map nothing doing, he's whatever input stream you are giving, same elements it is printing. Our input stream was 2 6 4, some 2 4 6 after sorted, right. After that if we will call that map, it is returning that same element, he's saying I'm giving the returning same element, you do whatever you want. I will take that, and what I will do, i will uh, I will suppose multiply into 2, something like that. So after that I'm printing. So you see, it was 2, 2 become 4, 4 become 8, 6 become 12, like that. So instead of printing we can count it, we can even we can sum it, that count sum, these are the terminate operations, okay. So we can do lot of things, okay. So you see how it is working, this filter, if you see this filter expecting a predicate, it's expecting a predicate interface, okay. What is predicate interface? That is like a interface. It is a functional interface, right? That predicate interface, I created a separate session, you can go through it for more detail, but anyhow I will explain a little bit here. So it is a functional interface. So that interface, it is taking one argument and it is checking whether it is true or false. It is returning a boolean value. Okay, so here this predicate, it is taking and it is returning a boolean value. It is having test, it is returning a boolean value. So instead of passing this implementation here, we can pass a predicate object, the implementation of predicate interface object. Let we can do like this. What I will do, I will create a object of that predicate interface. Okay, let's say I will by using that anonymous class. Okay, I can create a predicate object, pred equal to new. Okay, this is a functional interface, and if you go to that predicate, there is a test method, right? We need to override this test method. I will override this test method, and here whatever element we are passing, we'll check that element. If t percentile 2 equal to 0, that means if it is a even number, the t we can define it is integer, right? And here this is integer. Okay, we are defining the type, we are working in integer. Okay, and whatever it is integer element is coming, we are checking whether it is percentile 2 equal to 0. If it is yes, then it is a even number, then return that, otherwise don't return. That means instead of, it is taking that predicate object implementation, right? So as I showed you here, it is taking that predicate, right? So what we will do, we'll remove this and we'll pass that pred, this object. Okay, and you see we need to define this type. That's what this warning. So you see, still we are getting the same result, right? So instead of passing that, we are passing a pred object. So this is anonymous class. By using this anonymous class, we initialized, means we implemented this predicate functional interface. We implemented this method. So what happened actually? This anonymous class can be converted to Lambda expressions. How to do that? So you see this predicate, and it is having a test method. If we implement it, we need to override this test method. All these things, it is already defined in this functional interface, right? So no need to define once again. So I will remove all this, even method name also. You see, I'm going to remove one curly bracket, starting curly bracket, right? Let for that I will remove this curly bracket first. Then I will remove this. And if even this type not required to mention, okay, and I will add a functional interface symbol, arrow mark. This is functional interface symbol. Okay, if you'll see this semicolon, nothing doing, I will remove. And if we have only one parameter, no need to define this moon bracket, I will remove that. And if we are having one statement, no need to define this curly bracket, not required, I am removing that. And return statement also not required, even it is not allowing, it is not explicitly mentioned. Okay, if one statement, it will return. Okay, so now also you see, now also it will work. So that anonymous class, multiple lines is there. Instead of that anonymous class, by using this lambda expression, we can make it shorter, right? So this shorter code we can pass, even not required to pass this reference. Why will assign to a variable, and that variable pass will pass directly this lambda expression here, and it will work. You see, so how simple it is. Like filter and sorted also, sorted not taking any parameter. If we are, it is integer object, right? So wrapper class already. So if you wanted to sort user different, suppose we are having employee object and we wanted to sort as per their name or salary. So in that case we need to pass that sorted comparator, that is different. Okay, so here only sorted. And map also, if you take that map, it is taking a functional interface object. So that way you need to understand. Okay, so then we are printing. Okay, so even we can, suppose we got this, right? We got this 4 8 12, this list, right? And I wanted to add it. Okay, so I can call that terminate operations instead